Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module, that is a new module that we have started in the last class, that is a database design concepts, and I'm going to continue with the same chapter, that is chapter number 1, that is the introduction to the database. In the last class we have covered 1-2 topics of the database because there are less number of students that is available in the class, so there is no point of discussing the new chapter or starting the new chapter in a very good pace. So we have started with just the introduction, what is all about the chapters, how the chapters look like, what is the content of each chapter, and how to make that chapter very fruitful and sufficient for the users to demonstrate the weaknesses, to demonstrate the weaknesses of the database and to enhance the scalability of the database. So let's start with the previous class session and then move to today's topic, that is database languages, that is what are the various database languages that is available in the database. So we have started with the book. This is the book, that is a course. There is a PDF that is available. I will share this book in the today's class only. After the class, you can give the email ID to me. If I have not, then I will supply the books to, or I will pass the books in the class only, so that there is no point of forgetting the mailing, forgetting the point, right? So let's start with the various content. So we have studied about the content. There are different chapters in this book. We can see the different categories in this book. First is introduction of this chapter, that is the chapter number 1, that is the introduction. Then in introduction there is an introductory to the database, that is what is the database and how the database looks like. Then part 1 is relational databases, that is what is a relational database and how the relational databases are used. There is a usage of the relational database, or what is the meaning of the relational model, database schema, key, semantic diagram, and etc. Then next chapter is SQL. So we have studied about these various parts. Then part 2 is database design. So part 1 is relational database, then part 2 is database design. Then in this there are multiple chapters. Then part 3 is data storage and querying. Then part 4 is transaction management. Then part 5 is system architecture. Then part 6 is data warehousing, data mining, and information retrieval. In this there are multiple chapters. Then part 7 is special databases or specialty databases, that is what are the special databases that is available. Then part 8 is advanced topics. Then part 9 is case studies. So these are the multiple chapters that is available in this book, and the part 10 is appendices about the book. And we have started with the chapter number 1, that is the introduction of the database. So let's start again with previous introduction of the previous class session. So we have started with the introduction of the database, that is what is the DBMS, just the introduction. So DBMS is a collection of related information or collection of interrelated data and set of programs to access those data. So it is a collection of interrelated data. When the data is interrelated with each other and there are various programs to access those data or to deal with those data, that is known as the DBMS. So it is a collection of interrelated data and a set of programs to access those data. The collection of data usually refers to a database. So whenever we collect multiple data, that is known as a database. And whenever we use multiple programs to access those data, to verify those data, to retrieve those data, that is known as the DBMS. So DBMS is database management system. That is a system that is used to manage the database, that is a DBMS. What is the primary goal is to store the data in a database and retrieve the database information that is both convenient and efficient. That is also the main goal of the or primary goal of the DBMS, that is the database management system. Database systems are designed to manage large bodies of information. Management of data involves both defining the structure for storing information and providing mechanism for the manipulation of information. That is, we can store the data, we can manipulate the data with the help of the DBMS, that is a database management system. Then 1.1 is database system application. That is what are the various application areas in which the database system or the database is used. That is the database system applications. So first application in which the database management system is used is the enterprise information. That is it is used in the enterprises for various purposes, like it is used in enterprise for the sales department, for accounts department, for human resource department, for manufacturing department. So these are the various departments in which the enterprise, or by which the enterprise uses the database management system, that is the DBMS. Then banking and finance, that is the next part, that is the next application area in which the database management is used, that is the banking and the finance. How it is used, what is the amount receivable, what is the amount payable, what are the various credit card transactions, finance, that is the sale purchase of the financial institutions or instruments. So these are all related with the banking and finance. So one of the application area is enterprise, and the next application area is banking and finance. Then next is universities. It is also used in universities for the upgradation of the result, for the upgradation of various students. Then it is used in airlines for the reservation system, for the schedule information. So this is also used in the airline reservation system. Then telecommunication. That is, telecommunication means how to communicate with each other. That is also used by the or that is also one of the major application area of the DBMS. Then we have studied about what is the main purpose of database management system. That is why we are dealing with the database management system. That is what is the main target of the database management system. That is the purpose of database systems. So this says the database system arose in response to the early method of computerized management of the commercial data. So whenever we use early methods of the computerized management of the commercial data, so there is an enhancement, there is a requirement of the database system, so that we can maintain the data at a centralized location, or we can say the keep the data at a centralized location, so that it can be updated, or it can be used to provide the relevant data whenever it is needed. So that is the main purpose of database systems. And there are various programs, or there are various purposes by which we can access the database management systems. Then we have studied about the disadvantages of the database management system. That is, what are the various limitations of database management system. These are the various limitations of database management system. The first one is data redundancy. That is, there is a duplication of data whenever we store the data in a database. So if I store the data for a student, that student data will be entered in a student profile, in a we can say the school profile, in a teacher profile. So the same data will be we can say the repeated at the multiple places. So there is a data redundancy. That is also one of the, we can say, the one of the disadvantages of the database management system. And the inconsistency, that is a inconsistent data, that is a data is not consistent, that is, it is scattered to the various places, or it is scattered in a various places. Then there is a difficulty in accessing the data. That is also the limitation, that there is a difficulty in accessing the data. That is, how to access the data. That is also the limitation of the database management system. Then data isolation, that is, the data are scattered at the various places, so it is very difficult to compile all the data in the database. That is also the main limitation of the database management system. Then integrity problems, that is, there is also an integrity problem, constraint problem. That is how we can combine multiple data together if they are not interlinked with each other. That is, if they are not interrelated with each other, how we can compile the data, how we can isolate, or how we can combine the data from the multiple places. For example, files with a different format like JPG, MPG, there are various format that is available to how to compile the data, or how to merge the data from the various formats. The next is atomicity problem. There is also a problem of the atomicity. That is also a problem that is caused by the failure. That is the atomicity problem. In many applications, it is crucial that if a failure occurs, the data would be restored to the consistent state that existed prior to the failure. That is also the atomicity problem, that is the failure in the path. Then concurrent access anomalies, that is also the next part. That is how to, or this is also the limitation, that is how to access the anomalies, that is in the concurrent use, that is the concurrent access anomalies. So for the sake of overall performance of the system and faster response, many systems allow multiple users to update the data simultaneously. That is, there is also a data that is used or that is used to manage the data simultaneously. This is also one of the limitations, that is how to manage the data, that is a concurrent access anomalies. Then this is also the major disadvantage, that is the disadvantage of the database management system, that is a security problem. So the database is less secure because whenever we use the database, so there is a less security problems. The data is not secure because anyone can use the database. For example, if I'm purchasing something from the Google, or from any online shopping tool or the online shopping site, so there is a security problem because every user can access the data very easily. So there is a security loophole, so there will be a lack of security in the database management system. Then next topic what we have covered is the view of data. That is, what are the various view of data, or how we can see the database management system. That is a view of the data. So a database management system is a collection of interrelated data and a set of programs that allows the user to access and modify these data. The main purpose of database system is to provide users with an abstract view of the data. Abstract means providing the sufficient detail that is needed to retrieve the data. So there are multiple parts of the how we can view the data. The first part is data abstraction. That is, from the abstract level it is viewed. That is a data abstraction. So for the system to be usable, it must be retrieve data efficiently. The need for efficiency has led designers to use complex data structure to represent the data in a database. So whenever we use the data in a database, so there is a need for the efficient user, or there is need for the efficiency, that the designer must lead, or that the designer must know how to use the database or how to represent the data in the database. And there are multiple levels, or there are multiple we can say the types of the data abstraction. One is the physical level. It shows how the data are actually stored at the physical storage. That is, how data will be stored at the physical location, that is the how data are actually stored in the physical layer or the physical storage. Then logical level, that is the next higher level of the abstraction, that describes what data are stored in the database. One is the physical level, that is the how the data are stored. Then logical level, what type of data are stored. So one is how and one is what. Then view level, that describes only the part of the entire database, that is only view the database, only the describes only some part of the entire database, not the full database but some part of the entire database. And these are the various views that is available with the help of the diagram. First of all, there is a physical level that shows what data will be stored. Then logical level, sorry, physical level, how the data will be stored. Then logical level, what the data will be stored. Then there will be a view level, that is how users can view the data, that is the next layer, that is the view level. Then we have studied about the instances and the schemas. So instances means collection of information, collection of data in a database at a particular moment, that is known as the instance. And overall design of the database is known as the database schema, that is how the database will be designed, that is a database schema. Then next is data models, that is there are multiple data models that is also used, that is we are covering in the various chapters. One is a relational model that describes how different databases are related with each other. That is, this is a model that depicts in a graphical or graphically manner, that is how they are interlinked with each other, how they are related with each other, what are the various tables that is collected with each other. That is a relational model. And tables are also known as the relations. There are multiple relations that is used, that is a table will be used. There is a relational model. Then next is entity relationship model. Next is entity relationship model, that is how the entity relationship model will be used. That is how the ER diagram will be used, that is the entity relationship model. And there are next model is object-based model, that is the object-based data model, that is the next part. Then semi-structured data model, that is the next part. So there are multiple parts, there are multiple models that is available of the database. That is the relational model, ER model, object-based data model, and the semi-structured data model. Now, next topic is database languages. That is the today's topic or the today's class topic. So let's start with the database languages, and this is one of the important topic that is available with the database management system. So whenever we say the language, that means the way to communicate. So whenever we say the database language, the language in which or from by which we can use the database, or through which we can access the database, we can manipulate the database, we can operate on that database, that is known as the database languages. So a database system provides a data definition language to specify the database schema. That is, it provides a DDL, that is a data definition language, to specify the database schema. That is, the designing of the database is compiled or it used by using the data definition language. And data manipulation language to express the database queries. So one is data definition language that describes the database schema, that is the overall design of the database. Then data manipulation language to express the database queries, that is what are the various database queries and what are the various updates that is available. So in practice, data definition and the data manipulation languages are not two separate languages. Instead, they simply form parts of a single database language, such as widely used SQL language. These are not two different languages, that is the DDL and the DML, that is the data definition language and the data manipulation language. No, but they are using as a single language, single database language that is mostly widely used. For example, the SQL language, that is structured query language. So this is the language that uses both the both languages, that is the data definition language and the data manipulation language. Now let's start with the data manipulation language. Let's start with the first language, that is the DML, that is the data manipulation language. So this says a DML is a language that enables user to access or manipulate data as organized by the appropriate data model. So whenever we say about the DML, so DML is a language that enables users to access, so that helps the user how to access and manipulate the data as organized by the appropriate data model. That is how to access the data, how, that is how to access the data, how to use the data, and how to manipulate the data as organized by the, or as we can say the, as deal by the, or as it is used by the appropriate data model. So DML is simply a language that allows the users to access and manipulates the language or manipulates the data as more as the possible. The type of accesses are as follows. So there are multiple types of access that is available in the data definition language. So let's see what are the various types of the languages, or what are the various types of access that is available, or what are various types of manipulations, or what type of manipulations are used with the DML. So first one is retrieval of information that is stored in a database. That is how to retrieve the information that is stored in the database. That is also a category, or that is also a part of the DML, that is the database manipulation language. That is how to retrieve the information that is stored in the database. Then how to insert the new information into the database. That is also one part of the data definition language, that is insertion of the new information into the database. That is how to insert the new database, or how to insert the new records, new information in the database. Then deletion of the information from the database. That is how to delete the data from the database, or how to delete the various records in the from the database. That is a deletion of information from the database. So one is retrieval, one is insertion, one is deletion, one is modification. That is how to modify the data in the database. So these are the, we can say that these are the various operations, these are the various tasks that is done by the DML. That is how to retrieve, how to insert, how to delete, and how to modify. So insert, delete, modify, and the retrieved. Now there are two types of DML. One is the procedural DML, one is the declarative DLL. So procedure DLL requires a user to specify what data are needed and how to get those data. That is, that requires a user to specify, or that asks from the user to specify what type of data that you need. That is a procedure DML for manipulation purpose. Then after specifying what data are needed and how to get the data, then the next DML is declarative DML, that is also known as a non-procedural DML. So one is a procedural DML, one is a non-procedural DML. In procedural, user can specify what they want to study or what they want to need and how to get these data. And the next is non-procedural DML, that is a declarative DML, that requires a user to specify what data are needed without specifying how to get the data. That is, what are the data, or what are the what data are needed to complete, or what data are needed to have, or what data are required, without specifying the, or without getting the how to get the data. Simply takes how to fetch the data, that is a declarative DML. Now declarative DML are usually easier to learn and use and then the procedural DML. So it is very easy to use, it is very easy to learn the procedural DML. However, since a user does not have to specify how to get the data, the database system has to figure out an efficient means of accessing the data. That is, since a user does not specify how to get the data, how to retrieve the data, then the database system has to configure an efficient means of accessing the data. The next part is your declarative DML, that is also known as a non-procedural DML, that are usually easier to learn and use. That is easy to learn and use than the procedural DML, that is used to specify what the user needs, but declarative simply requires or specify what data are needed without specifying how to get the data. That simply shows the output, what type of data they are needed. So they are more easy to learn as compared to the procedural DMLs, right? Uh, Now, a query is a statement. So what is the meaning of the query? A query is a statement that requests the retrieval of information. So whenever I want to retrieve any information, whenever I want to retrieve any data, we are using the query. So that is a statement that is requesting the database, that is requesting the information, or there is a retrieval of the information. The portion of a DML that involves information retrieval is known as the query language. So this is a language that is a DML language, that is a data manipulation language that involves when information retrieval, that is known as a query language. So whenever we use or whenever we retrieved any data, that is known as the query language. Although technically incorrect, it is common practice to use the terms query language and database manipulation language or data manipulation language simultaneously. There are a number of database query languages in use, either commercially or experimentally. Now we will widely study query language SQL in chapter 3, 4, 5. So this is the answer to the Larry question, that is, what software or what database concept we are studying. So we are studying the SQL, that is the structured query language. The levels of abstraction is also discussed in 1.1, that may not applicable to define or structure the data, but also to manipulate the data. Now next is the data definition language, that is, what is the DDL, that is what is the data definition language, and how the data definition language will be used. So one is the DML, that is a data manipulation language, one is the DDL, that is a data definition language. So we can specify a database schema, we can specify the designing of the schema by a set of definitions that is expressed by a language. So we can set or we can specify the overall design of the database, that is how the database will be constructed, or the how or what is the main criteria of the database. To specify the database schema by a set of definition that is expressed by a special language that is known as the DDL. So we can use the DDL to express the language, to specify the language that is known as the DDL, that is the data definition language. The DDL is also used to specify additional properties of the data. That is, whenever I want to specify the various properties of the data, that is also specified by using the DDL, that is a data definition language. We specify the storage structure and access methods used by the database system by set of statements, that is in a special type of DDL that is known as the data storage and the definition language. So we can specify the storage structure, that is what is the storage structure and how to access, or what are the various access methods, that is also specified in a special type database language that is known as the data storage and the definition language. The data value that is stored in the database must contain certain consistency constraints, that is there are multiple constraints that is available, that is also known as the, or that is also provided by the database management system. DDL provides facilities to specify such constraints. Therefore, database implement integrity constraints that can be tested with minimum overhead. That is, what are the various constraints that is available, or what are the various issues that is available with the database. So first one is domain constraint. That is, the domain means we can say the group constraint. A domain of possible values must be associated with every attribute. For example, integer types, character types, datetime types. So whenever we use database, or whenever we use the constraint, that is a domain of possible values that must be associated with every attribute. Declaring an attribute to be a particular domain acts as a constraint on the value that it can take. Domain constraints are the most elementary form of integrity constraint. So this is one of the important type of the integrity constraint. So integrity constraint means providing the constraint on the values, or we can place the restrictions on the value. So one of the constraint is domain constraint, that is also the part of the constraint by which we can test the various system whenever a new item is entered into the database. So whenever a new item is entered in the database, that is a new item is entered in a domain, so we can test the item, we can check the item by using the domain constraint. Then next is referential integrity. So whenever we wish to ensure that a value appears in one relation for a given set of attributes, also appear in a certain set of attributes in another relation. So whenever we want to integrate, or whenever we want to integrate the reference, that is a referential integrity. So whenever we ensure that a value appears in one relation for a given set of attribute, also appears in the certain set of attributes in the other relations. So if there are two relations and both the activities and all the activities are interrelated with each other, that is known, or that is done by the referential integrity. And then next constraint is assertions. That is, assertions and condition that the database must always satisfy. That the database must satisfy the condition, must assertion that is given, or that is denoted by the assertions. Domain constraints and referential integrity constraints are special forms of assertions. Next, authorization. That is, the authorization means we can say the validation that we express. That is the most common authorization is the read authorization, which allows reading but not modification of data. Insert authorization that allows insertion of new data but not modification of the existing data. So there is a read authorization, insert authorization, update authorization, delete authorization, that is updation or modification but not the deletion of the data. Then delete authorization, that is deletion of the data, that is how to delete the data. So these are the various types of authorization. One is the read authorization, insert authorization, update authorization, and delete authorizations. The DDL, just any programming language, gets an input, some statements, and generates some output. Now, what is the output of the DDL? That is a data dictionary that contains the metadata. As the name advises, data dictionary, that is a collection of various data. So we can say the metadata, that is the data about the data. That is also given, that is the data about the data. That is a data dictionary that is considered as a special type of table that can be or that can only be accessed and uploaded or updated by the database system itself. So these are the two languages, these are the two programming, we can say the database languages that is used. One is the DDL, one is the DML. DDL is simply used to specify the structure, and DML is used to, we can say, how to manipulate the data. And DDL is how to store the data and how to access the data, and the DML is how to manipulate the data. So we are finished with the DDL and the DML. Now next topic is the relational database. That is, what is a relational database? So a relational database is based on the relational model and uses a collection of tables. As the name advises, relational database, that is a collection of multiple data, collection of multiple tables, that is a relational model. So a relational database is based on the relational model and uses a collection of tables to represent both data and the relationship among these data. That represents, or it uses, or it represents, that is a collection of the tables. That is, whenever we collect multiple tables, that is also the database, and whenever we combine multiple tables in a relation to represent both the data and the relationship among these data, that is a relational database. So it represents the data as well as what is the relationship among these data, that is represented by the relational database. It also includes a DML and the DDL, that is the data manipulation language and the data definition language. Now, these are the multiple chapter, that is given the relational model example, integrity, and what are the various languages. Now, what is a table? So every table has a multiple column and each column has a unique name. So we can say the table is a combination of rows and the columns, and every table has a multiple columns and each column has a unique name. So each column has some unique name and there are multiple columns in the table. Figure 1.2 represents a simple relational database comprising two tables. One shows the details of the university instructors and the other shows the details of the various university departments. That is the university instructors and university department. This is the table, that is the instructor table, and this is the department table. In the instructor table there is the ID, there is a name, department name, salary. That what is the ID, what is the name of the employee, what is the department in which they belong, and what is the salary that the employee gets in. And this is a department table, that is a department name, then building, what is the building from or where the department is situated, and then budget, what is the budget of the building or what is the budget of the department. So first table is the instructor table and the next table is the department table that is used. And the instructor table, there are multiple fields, there are multiple column headings like ID, name, department, and the salary. And in the department table there is a department name, there is a building, and there is a target or there is a budget. So a table is a collection of the rows and the columns, and each column has a multiple heading, or as each column has a unique name. The first table, that is the instructor table, shows for example that an instructor name Einstein with the ID, that is a member of the physics department, as an annual salary of 95,000. This is just we can say explanation of the table that is used. These are the examples of the relational model, that is how these tables are interrelated with each other, because the department name is same, or the department name is common in both the tables, that is the instructor table and the department table. So these tables are interrelated with each other, and it can be represented by using the relational model. So we can use the relational model to we can say to show the relationship between these two tables, that is the instructor table and the department table. Now next is data manipulation language, that is a structured query language, that is a non-procedural language. A query takes an input several data, that is possibly one by one, and always return a single table. So it always return a single table, always return a various values, always return a several table that is used for returning a single table. The next is the example of the structured query language, that is a SQL query that finds the name of all the instructors in the history department. That what is the name of the history department. Then what is the name? That is a select instructor name from instructor, where instructor dot department name equals to history. So find out the instructor name from the instructor table, or from the table name, that is the instructor, where instructor department name. So choose the instructor name where the department name is the history. So select the instructor name from the instructor table where the department name is history. Now if I check out, the department name is history, the department name of history is available over here. Then choose the instructor name, that is California, and yeah, the query specifies those rows of the instructor whose department or where the department name is history must be retrieved. So this will be an example that is retrieved. And the query may also involve the information from more than one table. That is, within a query we can use more than one table at the same time also. That is, select instructor.id department name. Why instructor.id? This is the name of the first table and the id is the field that is taken. This is the, we can say, the field, or we can say the attribute or column of the, or name of the next table, that is a department table, and the department name is the field or the column that is used with the, or that is accessed with the department table, that is the department.dpt id, that is a department name, not id but name, from the instructor, from the department. So we are using both the tables, so give the name of both the tables, that is the instructor and the department. Now check the condition. What is the condition? Where instructor dot department name, that is where the instructor table dot department name equals to department dot department name, and department dot budget is greater than 95,000. So this is the condition, that is a find out the instructor ID and the department name from multiple tables. Now what is the condition? Where both the values, where both the department name are the same, that is the instructor table also same department name, and the department are also the same department name, and the budget is greater than the 95,000. There are three conditions: where the department name is similar, and where the budget is greater than the 95,000. So if the above query were run on the table in table 1.2, the system would find there are two departments with budget of greater than 95,000, that is a computer science and finance. So the budget is greater than the 95,000 that is given, and there are two terms that is a common, greater than 95,000. This is greater than 95,000, that is computer science, physics and the finance. There are three fields: computer science, physics and the finance. So this is, there are three tables, there are five instructors that is available, that is a computer science and the finance, that is greater than the 95,000. Okay, greater than 90, computer and the finance. This is the finance, that is a 95, 90,000. But here the computer science has a 1 lakh and the finance has a 120, that is a greater than the 95,000. So there are two categories, there are two department name that is available, and there are five instructors in these department. There are five instructors in these department, that is a tailor, then this is a tailor, sorry, this is a Srinivas, then there will be a brand, that there will be cats. These three are from computer science, and for the finance there is a WO, there is a sing. There are two more, that is for the finance. So there are total 5 records that is displayed. Therefore, the result will be a table that contains the 5 rows, that is the finance, computer science, computer science, computer science, and the finance. So there are 5 records that is displayed. This is just an example that shows how to use the multiple tables with the query, that is how to use or how to combine multiple tables like instructor.id, that is the ID is taken or ID is taken from the instructor table, and the department name is taken from the department table, and choose the both table, that is the instructor and the department, and checking the condition, that is instructor dot department name equals to department dot department name. Check the condition that both the department name have a similar name, or the both table have a department name that is the same, and the budget is greater than the 95,000, not equals to 95,000 but greater than the 95,000. Now next is a DDL, that is a data definition language. So SQL provides a rich DDL that allows one to define tables, integrity constraints, assertions, and etc. So SQL provides a rich DDL, that is a data definition language, that allows ones to define tables, that is how to define the tables, integrity constraints, exceptions, etc. For example, the following SQL DDL statement defines the department table. So this is a table, or this is the, we can say, the example that shows how the DDL statement, that is the data definition language statement, would represent or defines the department table. So this is one of the example. So this is the data definition language. This is used for creating the table. So create a table. Now name of the table is department, and these are the multiple fields, and these are the various data type that is required, or what is the type of the fields that is available. So one of the field is department name, that is one of the column heading is the department name, that is the name of the department, that is of the type char. So this is of the type char, that contains the 20 characters. So this is for the char 20. So it takes the value as a character as a string that contains 20 character from 0 to 19. So this takes a department name as a string, or the type is a string. Then next is the building, that is also the field, that is also the column heading that is available, that is building, that also contains, or that is also of the string type, that is a char 15. Then budget, that is a numeric, that is a number that takes the value as a 12 and the 2. So this is execution of the above statement creates the department table with 3 columns. What are the 3 columns? Department name, building, and the budget. Each of which has a specific data type associated with each. For this there is a char, that is a string. This is a char, that is a string. There is a numeric, that is a number. Now next is database access from the application programs. That is how to access the database application, or how to access the database from various machines, from various data, or from various application programs. That is from the Office, from the SQL, or from the C++, C. What are the how to access the database? So SQL is not as powerful as universal turing machine. That is, there are some computations that are possible using a general purpose computing or programming languages, but are not possible using SQL. That is, it is not possible to use the SQL at all the times, that is structured query language, to use the or to make the database, or to access the database from various application programs. SQL also does not support actions such as input from users, output to display, or communication over the network. Such computations must be written in a language, that is C, C++, with embedded SQL queries that access the data in the database. So these are the various languages, these are the various application program that is used to access the database, or that is used to create or embed the or use the SQL queries that access the data in the database. So This uses, or these application programs uses the SQL queries, that is the SQL queries, to access the data in the database. Application programs are programs that are used to interact with the database in this fashion. As I told you, whenever we use any application program to interact with the database with the use of the SQL languages, that is done by the that is known as the database access using the application program. Example in a university system are programs that allows the student to register for course, generate class roster, calculate student GPA, generate the payroll check, etc. To access the data, DML statement need to be executed from the host language. And there are two ways to do this. How is that possible? That is how we are using the database languages, or how it is possible to access the database languages. So the first way is by providing an application program interface, that is a set of procedure that is used to send the DML and the DDL languages to the database. So one of the method is using the DML and the DDL language to retrieve the result. And there is a concept that is known as the ODBC, that is the Open Database Connectivity, that is a standard language, or that is a standard connectivity, or that is a standard method that is used with the C language, and it mostly used application program interface standard. So it is one of the most application program that is used, that is ODBC. And the JDBC, that is a Java database connectivity, that provides the corresponding features to the Java language. So ODBC, that is the Open Database Connectivity, that is used with the C language, and the JDBC, that is used with the Java language. And by extending the host language, the next method is by extending the host language, that is a syntax to embed the DML within the host language program. Usually a special character preface, that is a DML, is used, that is known as a DML precompiler, that converts the DML statement to the normal procedure codes in the host language. So this is the next part, or this is the second part, how we can, or how the DML statement can be executed from the host languages. So last line says the DML precompiler converts the DML statement to the normal procedure. So there is a conversion that converts the DML statement, that converts the DML theories or the execution part into normal procedure calls in the host language. There are two methods using the DML precompiler, using the ODBC and the JDBC. Right. So next part is database design. So what are the various issues that is available with the database design, or what are the categories of database design? So let's take a break right now. Then after the break, moves to this topic, that is a database design. So let's take a break right now. So come back from the break. Now let's start the session again. Now the next topic is database design. That is, what is the database design, or how to design the database, what are the various concepts, what are the various, we can say, the constraints, rules, regulation that is followed using the in the database design. So that the database design. So database systems are designed to manage large bodies of information. So database design are used or managed or to manage the large bodies of information. These large bodies of information do not exist in isolation. That is, whenever we design the database, so that are designed to manage the large bodies, that is a huge number of bodies of information. These large numbers of information does not exist in isolation. That is, they are not available in the isolation in the part. They are part of the operation of some enterprises whose end product may be the information from the database, or maybe some device or service for which the database plays only a supporting role. So in simple terms, database are designed to scatter or to handle multiple data, or the data that is in the isolation, that is available in isolation. Database design mainly involves the design of the database schema. That is, a schema means that is the overall design. So database design generally involves the overall design of the database, or that is what is the look and feel of the database, or how the database is looking at the criteria by which the database systems are used. That is the database schema. The design of a complete database application environment that meets the end of the enterprise being modeled require attention to a broader set of values. That is, there are multiple values, there are multiple criteria that is available with the database that is used with the various concepts of the database that is covered under the database criteria. In this context, text, we focus initially on the writing of the database queries and the design of the database schema. So in this chapter, in this topic, we generally focus on the what are the database queries and what are the ways design of the database schema, or how to design the database schema. Schema means overall designing of the database. Now, there is a first topic is design process. That is, what is the design process, or how to design the database. So, a high-level data model provides the database designer with a conceptual framework in which to specify the data requirements of the database users, and how the database will be structured to fulfill these requirements. So, a high-level data model provides the database designers or that provides a database designer to how to use the, or what are the conceptual framework, or what is the conceptual framework that is audible, or that is visible to or that is we can say that that is automatically visible to the database design. Now, Larry, are you able to hear me right now? Larry, are you able to hear me right now? My voice is not audible to you. Hello, Larry. Hello. Yeah, Larry, are you able to get me what I'm trying to say? Hello. One of the students, that is a Larry, is not audible with the voice, so it's his message came that the voice is not audible. I don't know why. So let's continue. So there is a design process, that is how to design the database. What is the process that is followed to design the database? Yeah, Larry, are you able to hear me right now? Larry, are you able to hear me right now? So that is a design process. That is this is a high-level data model provides the database designers with a conceptual framework in which to specify the data requirements of the database users. That is, what are the various data requirement, or what are the requirement of the database users, and how the database will be constructed or structured to fulfill these requirements. That is, what are the requirements of the database, what are the various issues that is available with the database, what are the various requirements of the database users, and how the database will be structured to fulfill the requirement. The initial phase of the database design is to characterize fully the we can say the data needs of the prospective database user. So first of all, take out the needs of the database user. What is the need of the database user, or what the user wants from a database? That is the first priority, that is the first phase by which we can extract the database. The outcome of this phase is the specification of user's requirement. That is specification of the user's requirement, what the user specify, what is the requirement of the user, what they need from the database, or which type of database, or what type of database that they require. And then next, the designer chooses the data model. So first of all, specify or take the user's requirement, that is what is the user's requirement, what the user wants. Now the next step is the designer, that is a programmer, chooses the data model. Which data model is used? That is a physical data model, logical data model, conceptual data model, that is which physical or which data model is used. And by applying the concept of the chosen data model, translate these requirement into a conceptual schema of the database. That is, translate the requirement, translate the modify the requirement into a conceptual schema of the database. The schema developed at this conceptual design phase provides a detailed overview of the enterprise. So whatever the schema that is developed at this conceptual design phase provides a detailed overview of the enterprise that is available. The designer reviews the schema to confirm that all the data requirements are indeed satisfied and are not in conflict with one another. The designer can also examine the design to remove any redundant features. The focus at this point is on describing the data and their relationship rather than on specifying the physical storage devices. So what's the focus? Designer focus after specifying the database design, after specifying the requirement of the user. The focus is on describing the data, that is how to describe the data and what is the relationship between among the interrelated data rather than specifies the physical storage details. So it is not, we can say, it is not required to specify the details of the storage, physical storage, but it's better to use the, it's better to focus on the describing the data and their relationships. So in terms of the relational model, the conceptual design process involves decisions on what attributes we want to capture in the database and how to group these attributes to form the various tables. So what is basically a business decision and not discussed in this text. Then how the database designed for a university organization. So this is just an example how to design the database for a university organization. If there is one university, so how to organize the data or how to build the data or how to design the database for a university. Okay Larry, it's okay. How to design the database for a university organizations. So these are the various characteristics of the university. That is, the university is organized into various departments. Each department is identified by a unique name and is located in a particular building as has a budget. And each department has a list of courses it offers, and each course has associated it a course ID, title, department name, credits, and may also associated prerequisite. And these are the various requirements that university maintains a list of classrooms specifying the name of the building, room number, and the room capacity. The department has a list of teaching assignments specifying for each instructor the sections the instructor is teaching. And the university has a list of all the candidate student course registrations specifying for each student the courses and the associated section that the student has taken. That is, what is the requirement of the what is the university requirement, what is the requirement of the user. So that is also the next phase. So this is just we can say the database design for a university organization. That is how the database will be designed for any university. Then next is ER model, that is the entity relationship model. That is a collection of or uses a collection of basic objects like entities, relationship among these objects. So it is a collection of various objects that are known as entity, and how to show the or how to adjust the or how to take the relationship among these objects. So if a question arises, what is an entity? So an entity is a thing or an object in the real world that is distinguishable from another object. So that is only the unique object that is undertaken, that is known as the entity. For example, each person is an entity and the bank accounts can be considered as an entities. So every person that is taken is an entity and the bank account that can be considered is also as an entity. Entities are described in a database by a set of attributes. So whenever I want to describe the database, that is, I want to describe the entity, that entity are described in a database by a set of attributes. There are a set of attributes that is available in the database design. For example, the attributes department name, building, and budget may describe one particular department in an organization. So if I am saying about the attribute, that is a department name, that is a building, that is a budget, that may also describe one particular department in a university, that forms the attributes of the department entity set. In a similar way, the attributes like ID, name, salary may describe an instructor entity. So there are entities that are described in a database that is known as the set of attributes. The extra attribute ID is used to identify an instructor uniquely. A unique instructor identifier must be assigned to each instructor. That is, a unique instructor will be assigned to each identifier. And what is a relationship? That is an association among the several entities. For example, a member relationship associate an instructor with a department. So this is just showing that the ER model is used to show the relationship among the various entities. For example, if I'm saying about the university example, that is a university example database design. So whenever a database designed for a university, there are multiple universities, lecturers, teachers, that is known as the entities. So whenever we say about the entity, that is a thing or an object that is differentiable with each other. For example, a person is an entity, bank account is an entity. So there are various entities that is also available. For example, the attribute department name, building, budget may describe one particular department in your university. The overall logical structure, that is a schema of a database, can be expressed graphically by the ER diagram, that is the entity relationship diagram. So whenever we say the overall logical structure, that is a schema of a database, that is the overall design of a database, can be expressed graphically. So there is also a method, there is also a way by which we can express the logical structure, by which we can express the database design, that is a schema of a database, that can be expressed graphically by a ER model, that is entity relationship model. There are several ways in which we can draw these model, and one of the most popular approach is using the UML, that is a unified modeling language. So this is the sample of the ER diagram. There is an instructor, this is the ID, name, salary. These are the three attributes that is used. Then department, and these are the three parts, that is the department name, building, budget, and this is the member. So ID, what is the relationship? That the instructor is a member in the department. So there is one department, that is for example computer science, and the instructor, for example Sham. So Sham is a instructor that is or that is available, or that works in a department, that is a computer science. Now entity sets are represented by a rectangular box. This is one of the important. This is the entity that represent in a particular or rectangular box with the entity set name in a header and the attribute listed below it. So this is the header, and these are the various attribute that is listed below it. These are the various these are the various attributes of the we can say the entity set in the header. In the same way, this is also entity, that is a department, and these are the various attribute sets that is available in this header. And relationship sets are represented by a diamond. This is a relationship that is represented by a diamond that connects a pair of related entity sets. This is also related, this is also related. The name of the relationship is placed in the inside the diamond. This is a relationship. What is the relationship? The instructor is a member of the department. This is a relationship among the instructor and the department. As an example, consider the part of the university database that consists of an instructor and the departments. Now next is normalization. That is simply a method for designing a relational model that uses a process that is known as a normalization. The goal is to generate a set of relation schema that allows to store information without unnecessary redundancy, yet also allows to retrieve the information very easily. So normalization is a process by which we can remove the redundancy, or in simple terms by which we can sort out the table, by which we can simplify our table, our database, so that there is no requirement, there is no schema, there is no unnecessary redundancy in the database, and also allows us to retrieve the information very easily. So if there is no duplication, no redundancy that is available, so there is no or there is a easy chance to retrieve the data, or there is a easy chance to retrieve the or update the information very easily. The approach is to design schemas that are in an appropriate normal form. The most common approach is the functional dependencies that is available. To understand the need of the normalization, let us look what is going wrong in the bad database design. So what is a bad database design? That contains a repetition of information. So if a database contains a repetition of information, that is a bad design or bad database design. Then inability to represent certain features or certain information. So there is an inability to represent the various information, certain features. So this is the, we can say, the faculty table. This is the ID, this is the name, this is the salary, this is the department name, building, budget. These are the various columns heading. These are the various, we can say, the attributes that is given in a table. One is ID, one is the name, then salary, department name, building, and the budget. And these are the various fields in this table. One of the ID is 22222, then instant, salary, department, building, then the budget. Now next is data storage and querying. Next topic is how to store the data and how to query the data, that is the data storage and querying. So how to store the data and how to retrieve the data, that is done by the query, that is retrieve the data and store the data, that is the data storage and querying. So a database system is partitioned into different modules that deals with each of the responsibilities of the overall system. So a database design or the database concept that is related or that is partitioned into various modules, that is divided into various modules, that is a database system that deals with each of the responsibilities of the overall system. The function components of a database system can be broadly divided into two categories, that is the storage manager and the query processor component. That is the how to store the data, that is done by the storage manager, and how to process the query or how to retrieve the data, that is done by the query processor components. Right. The storage manager is very important because database typically requires a large amount of storage space. And query processor is very important because it helps the database design or it helps the database system to simplify and facilitates access to data. That is how to simplify or how to simply use the data and facilitates the access to the data. That is used to simplify and facilitates access to the data. So first is the storage manager, that is the first part. So storage manager is a component of a database design that provides the interface between the low level data that is stored in a database and the application program. So whenever we say about the storage manager, that is the main component of a database system that provides the interface between the low level data stored in a database and the application programs, and the query is submitted to the system. Now, what are the various components of the storage manager? That includes the authorization, integrity manager, transaction manager, file manager, buffer manager. So these are the various managers. These are the various storage manager components that is available. The storage manager implements several data structures like data files, data dictionary, indices. So these are the various storage area in which we can store the data like data files, data dictionary, indices. Then the query processor, that is how to process the query or how to, we can say, the how to make the query language or how to use the query language, that is the query processor. So that includes DDL interpreter, that is the data definition language interpreter, and DML compiler. So with the use of DDL interpreter that interprets the DDL commands or the statements and records the definition in the data dictionary. In the same way, DDL compiler which translates the DML language, sorry, DML compiler. So one is a DDL interpreter that interprets the DDL commands, one is a DML compiler that translates the DML statement into a query language. Then query evaluation engine that executes the low level instruction that is generated by the DML compiler. Next is transaction management, that is how to use the transaction management. I'm not going to continue with the transaction management because this is theoretical topic, but this is less topic, so we can continue with this one. So next is the transaction management, that is how to manage the transactions, or what is the management capabilities that is used with the transactions. So one of the main criteria that is used, that is the transaction management, that is atomicity. That is atomicity means there are multiple par failure that is also available. So this correct requirement is the consistency. So whatever the management of the transaction, how the transaction will be managed, that is provided by the inconsistency or the consistency. A transaction is a collection of various operations. So whenever I combine various operations, that is known as a transaction that performs a single logical function into a database application. So whenever I collect various operations that performs a single logical functions into a database application. Each transaction is a unit of both atomicity and the consistency. So transaction is a collection of operations that contains logical functions, and each transaction has combined, or is a combination of both atomicity and the consistency. And there is also a recovery manager that is recovers if the failure occurs. So all the transactions are completely recovered by the recover manager. And the transaction manager consists of the concurrency control manager and the recovery manager. This is all we have discussed in the, or we are going to discuss in the next chapters. Now next is database architecture. This I am going to continue in the next class. That is what is the database architecture, or what is how the architecture will be built, right? So let's stop the class over here only. In the next class, that is in the tomorrow's class, I am taking your next topic, that is the database architecture. Now if there is any doubt, any suggestions, you can ask from me, and immediately I will do the mail to you for this database design concepts. So any doubts, anyone, you can ask the doubts from me. So that's all for today's session. Thank you so much everyone. Bye bye.
Hello, sir.
Yes, Joseph.
Hello, sir.
Yes, Joseph, tell me.
Good evening, sir.
Good evening. How are you?
Yeah. Please, sir, ODBC, what does it, what, I'm fine. What is the application of ODBC
OD,
between a program's application and the database?
for
What is
example,
the work of ODBC?
we have studied the C language. We have studied about the file handling, right?
Hello, sir.
Hello. Yeah, are you able to hear me?
Hello.
Hello. Yeah, are you able to hear me? Hello. Hello.
Hello.
Yeah,
Yes, I can hear you now.
are you able to hear me,
Yes,
Joseph?
I can hear you now.
Okay. So Joseph, what we have studied in the C language, there is a file handling
I
topic.
can hear you now.
There is a file handling topic. We have studied the file handling.
I can hear you now.
We have studied about the file handling topic, right, in the C language. Hello. Hello. Yeah, Joseph.
Yes.
Uh, we have studied the C language. We have
Yes,
studied.
I can hear you.
Okay, Joseph, listen carefully.
I can hear you.
Hello. We have studied about the file handling topic in the C language. So whenever we use the file handling,
I
so
can hear you now.
yeah, are you able to hear me right now? Now it's audible to you.
Yes, I can hear you now.
So whenever we use the
Yes, sir.
so whenever we use the C language, there is a file handling concept. We have studied about the file handling in C language, right? So whenever we use the C language, there is a file that stores some data. So where the data has gone? Data has gone into the C language. Data has gone into the database by using the ODBC. So ODBC generally provides the connectivity with the C language. That is the open database connectivity. So whenever I combine the database with the C language, that is done by the ODBC. All right, Joseph.